Okay, so hello. So here we have a bottle line simulation using Logix Pro Simulator program. So as you can see here, we have like many type of instruction. We have a timer, we have bit shift left, we have a limit test, we use the counter arc, we use TOD instruction. So here for our first rank, the rank 0, to initialize the program, we have a start button. So this start button, which is here, when we press on it, it will activate a run light, which is here, and it will activate the whole program because we are using an MCR here. So when the MCR is activated, then the whole program will be activated, because the MCR, like if the MCR is not activated, then whatever happening here in the input, if they are on or off, the output here will be always off. That's if the MCR is not activated. So to activate the MCR, we have to press the start button in a condition that the stop button is not pressed. So here, like for example, if we press the start button, we can see that our program is running, the run light is on, and then if we press the stop button, then everything stops. Okay, so when the run light is activated, we have a limit switch 1, which is our first sensor here, that will detect the bottle. The sensor is used to detect if there is a bottle or not. This, when it is detected, this will activate a timer on delay from 0 to 10, which is 1 second because the time base is 0.1. So it's in 1 second, the main conveyor will stop, and then it will start for 1 second also. So it will start for 1 second and then stop for 1 second, start for 1 second, stop for 1 second. So when it reached 10 here, which is 1 second, so it will activate our third rank, basically, if we are counting this rank. So our second rank will be activated, and in a condition that LS4, LS5, and LS6 are not activated, which are LS5, LS4, LS6. If this input are not activated, then our main conveyor will run. However, if one of these input is activated, if it's filling up the bottle, then this conveyor will never work. And then and then our limit switch 1, the bottle sensor, will activate 2 BSL, bit shift left. One is bit tree 1 and one is bit tree 3. So this bit tree 1 that has the bit address I17 is for the LS2, the position of this position. So this position is to detect the big bottle. So we are using this one to know the position of the big bottle. We want to know the position of the big bottle here. We want to know the position of the big bottle here. And this the same, but for the broken bottle, which is the address, as you can see, is I18, which is this one. So it can detect the position of the bottle that passes by here, that later, like we want to know this bottle position, we want to know this position here, and we want to know this position here. It will be further explained later. So in our next rank, we have a limit test. Limit test is to activate an output when the input is between two limit, which is here from 2 to 5. So when the ACC of T4 of the timer 40 is between 2 and 5, then it will sorry, we are here 2 and 8, sorry. When the T40.ACC is between 2 and 8, it will activate the fill tube in one condition, that B335, which is for the broken bottle, B33, is not passing by. So B33, we said, is for the broken bottle, and 5 is the position after this position. So this is B33, this is 1, 2, 3, 4, 5. So whenever a broken bottle is here, this will never activate. This will never be activated. And then if there is no broken bottle, then the fill tube will work. For the next rank, LS4, which is this one, the filling tube, it will operate for two type of filling that we have here. large filling and small filling. So to know that, we are using the as we saw here in the bit shift left, the B31 condition, which is the B31, which is the position here, B31. So when the B31 0, this is B31 0, B31 1, 2, 3, 4, 5, 6, 7. When B31 7 is here, then this should activate the large fill. And when it is not B31 7, then it's a small fill. That's basically what happens here. So when it's B317 is activated, then it will activate the large fill, while when B317 is not activated, then it will activate the small fill. This is to differentiate between the big bottle and small bottle. For the next rung, we have the scrap gate and the cap RAM. So when the timer for 0 again is between 2 and 5, and the B339, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. When the B339 is activated, then the scrap gate will open. So basically, when the position that was high here is here, then this will open. So our broken bottle will go to the grinder. And this at the same time, it will activate also the cap RAM to close the bottles. Our B339 will activate the grinder, so basically when it's here, the grinder will be activated. And for the next rung, input 113, which is this limit switch. So when this sensor for the gate is on, then there will be a counter. It will activate a counter, so we'll know how many bottles are passing by here. So we put our limit is 12. So whenever there is 12 bottles, then the counter will be used here in the next rung. When the counter is done to 12, to operate the scrap conveyor. The scrap conveyor, which is this one. So this one will move. So another box will come here, and the counter will be reset and start again. This is to fill up this box, to fill up the other box, etc. And then we have, when the scrap conveyor is activated as well. No, this is already done. So when the V300 and V301 are activated, this will activate the limit switch 10. Okay, this will, and the limit switch 10 is activated, and this will activate V301. Okay, so basically yeah, so this is the continuing of the previous process. So here this will just move the conveyor for one position. It will move the box, sorry, for one position, from B300 to B301. And then here we have another limit test from 2 to 5, when the timer 4.040.acc is between 2 to 5. This will activate a driver gate, which will be used to separate the big bottle from the small bottle. So the big bottle will go down and the small bottle will stay up. We are using this, how to differentiate between them, by using B325. B325 is the same actually as B325 is this position. So it's the same actually as this is B31, sorry. So if we're counting from here, B31, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, until it's going to be 21. So if we're putting here B31 21, it's the same as B325. And B343 is for the broken bottle. So it's B33 to 19. So if we put this B33 to 19, is going to be the same as B343. So whenever it's not a broken bottle and it's a big bottle, then the divert gate will operate. And then when the main conveyor operates, it will while this B342 or B324, it will basically it will operate the divert conveyor here and move it for 1 bit only. So whenever there is a bottle here, this conveyor will move for 1 bit. Here in the 14th run, the limit switch number 6 is used to activate the output 211 and the counter C51. So this is used to count up how many small bottles we have. The input is, so this is input 110, this is the input 111. So this is to count how many small bottles we have, and this is to count how many big bottles we have. So to count the small bottles, we'll activate output 211. So whenever there is a bottle, it will activate the output 211, which is here. So the number will be here, and it will activate at the same time a counter up. So this will count the number of bottles passing by, and then later we'll use this this counter by using a BCD, a TOD, to send it to a BCD to send the number from C51 to the destination to the output 4, which is the BCD here. To count the big bottle, we used a jump to subroutine instruction. So for I1 10, it will send the information to jump to the instruction jump to subroutine. This subroutine is going to activate this function here. So whenever there is a bottle passing by, it will activate the count up, and then when the count up is activated, it will send the number in the counter here to the destination output 4, so the number can be seen here. So let's simulate our program and see what can it give us. So when we press the start process, it will count here how many small bottle. 5 small bottle, 6, 7, 8, 9. Okay. Now the large bottle has been detected. 2. And then also with the weight, this broken bottle will go here. As you can see, this broken bottle go here down. Yes, and the big bottle here will go here to separate the big bottles from the small bottles. And also this should be moved to another box when this reach 12. So if let's change to 10 and see what's happening when we add 2 more bottles. This box should move to the left and a new box should come. Okay. That's 11. Let's wait for 1 more bottle. So see, the next box came and it will repeat the counter reset again, and it will repeat until 12 bottles, and then it will move again, etc. So that's the end of the video. Thank you very much for watching.